Hello everybody, Javier Peña from University of Alabama. I'm very happy presenting this study titled uh, Examining Spatial Disparities in Safety Benefits from Automated Vehicle Adoption in Alabama and Kentucky. The recognition and acknowledgement for the whole thing here, but in special to Dr. Jun Liu. This was one of the last projects he led, really honored to be in this place, in this position at this time, representing him. Um, we have developed a video with the help of CR2C2 for this project. I'm gonna play this now, and then we can continue with the presentation.
Roads have always carried stories of journeys, families, hope, and sometimes tragedy. Every year, crashes disrupt lives, shatter dreams, and alter futures. What if technology could change the story, and the very roads that challenge us could one day save us?
For rural communities and their citizens to thrive, arriving safely as they travel is critical. Resources can be limited in rural areas, so every action that we take needs to make a tangible difference to the people we serve, and especially when we're talking about safety.
That's where the Center for Regional and Rural Connected Community researchers came in. What if the same advanced vehicle technologies transforming big cities could be adapted for small towns and farm roads?
We focus on connected and automated vehicles, or CVs, cars and trucks, that can communicate with each other, the roads, and even take on some driving tasks. Our goal wasn't to dream up a sci-fi future, it was to ask, realistically, what could CVs do for rural safety and what cost? We used cost-benefit analysis to find solutions that save the most lives with the resources available.
The research team analyzed crash data, demographics, and regional challenges. The results were clear. Rural areas had significantly more rollovers, while urban areas saw more rear-end crashes.
Technologies like automatic emergency braking, lane keeping assist, and vehicle to everything was then mapped to those crash patterns to see which offered the most benefit and how cost efficient each solution could be.
Rural roads add extra challenges. Narrow lanes, poor connectivity, and unpredictable conditions, they all make deploying technology more complicated. That is why we need smart, targeted investments rather than one-size-fits-all solutions.
To determine real-world impacts, the research team used a custom tool, SAFCAT, a simulation that predicts how different levels of CAV adoption could reduce crashes, save lives, and provide different levels of return on investment.
Along with better road markings and connectivity, adopting key technologies can help improve safety on rural roads. For example, studies have shown that automated braking systems can reduce rear-end crashes by 52%. Likewise, research has demonstrated that vehicle-to-vehicle communication systems can prevent more than 76% of crashes. But technology alone isn't enough. In rural communities, adoption lags due to cost and trust concerns. That means education, financial incentives, and infrastructure improvements are just as important as the vehicles themselves.
Our cost-benefit approach helps target investment where they are most needed, maximizing cost reduction per dollar and guiding policymakers on where and how to introduce these technologies effectively. And that's critical, most on areas where resources are limited. Beyond the numbers, this is a collaboration between students, researchers, and stakeholders in the local community. All of them came together to bridge the gap between innovation and the rural life.
This research is grounded in the roads we drive, the communities we love, and the possibility of making them safer for everyone, while ensuring every dollar invested makes a measurable difference.
right. So yeah, the video was good work summarizing the project, but I will go in a little bit of details of what was developed specifically. So looking backward, we identified that there are a lot of studies trying to understand how autonomous vehicles would be adopted in the future. They come from industry, they come from academia, and they are very sophisticated in terms of methodologies. They had been like a structural equation modeling with latent variables and so on. So in that area, if we want to get a result, we already have information and we have results. So that is one area of research. And then apart from that, we have the quantification of safety impacts for those technologies. So one of the most used methodologies, usually what they do is basically see to national crash databases and then assume if the autonomous vehicles were present during that time when the crashes happened, what could be the potential reduction? So they say at this year we have this number of crashes and the technologies that autonomous vehicles have could have prevented this percentage of this amount of crashes. And those are very aggregated level studies. So our question was, okay, from the adoption models, this research that we first identify, we can see that there are heterogeneous patterns geographically and also inside the same areas. Not all people are going to adopt the vehicles in the same rates. So we wanted to study if first the adoption was even across the states, and then how that will relate to the safety benefits on a more disaggregated level. In that way, we basically merged two methodologies. One is the safety, the autonomous vehicle adoption type of model, and then the other one is the crash safety methodologies. And we use Alabama and Kentucky as the study areas for this project. And then, as it has been mentioned before, many of the states in the Southeast are lacking information about how autonomous vehicles would be adopted in this case, for example. So we needed to adapt information from other areas. In this case, the Minnesota Travel Behavior Inventory was one good source of information that we kind of transfer from that area to the southern states. And in this data set, they have one quick key question. It was like, what is the interest on buying an autonomous vehicle? And also they collected information about sociodemographic and split the sample in between rural areas and urban areas, which was very important for us. And from this point, I will say we came up with an idea of further developing the study later. So the second phase of this project is collecting data about AV adoption in the southern east states, which we will be talking about that project later. But just to mention where that project started, what the idea came from. So returning to this project, the next step was to calculate a logic model, which will tell us if people has this type of sociodemographic characteristics, they are located in the rural or urban areas, they will have a potential probability of adopting an autonomous vehicle. So we kind of link the sociodemographic information to the AV adoption. That's the first step. And we calculated the percentage or the proportion for each census block group. So in this case, we can see that as we were expecting, it is not even across the states. So Alabama has some areas where autonomous vehicles will be more accepted than others. The same happens for Kentucky. But one question that remains here is if a person buys one vehicle in one census block group, that person will move around, and then the benefits from having that vehicle will be kind of spread. So we needed to answer that question, and the way to do that was to see origin and destination employment statistic information because it is very rich, it is very detailed at census block group level. So from that, we were able to extract what are the distribution patterns in terms of distance travel. And from that, we came to some interesting conclusions. We saw that the lower or the smaller the town, people will tend to travel longer distances, while on this other side of the graph, we can see that bigger population areas tend to work inside the same area. So if a person from a rural area is adopting an autonomous vehicle, they might be traveling longer distances, and then the safety features will be also benefiting all people across that distance. And this is kind of the representation on that. So we can see here, for example, Lexington and Birmingham areas in Lexington in Kentucky and Birmingham in Alabama. And then the closer the area to the city center, there are more influence in that area, but as distance increases, the impact or the effect will be less. So that's kind of to represent what would be the spillover or the distribution effects across the space. So with that, we calculated again the interest on buying autonomous vehicles, but in this case, weighted by these distribution effects. And we can see that some clusters are identified around urban areas, basically. So here we have Montgomery, which is the Alabama state capital, and then other urban areas are kind of dark in those maps. For the Kentucky, we have this triangle of the bigger cities in the state. But our rural areas are somehow left behind in this type of effects or adoption proportion. So our next step was, okay, we have identified what areas are more interested on buying cars, and we have also crash information, very detailed, extracted from Alabama and Kentucky Departments of Transportation. And we identified those areas with on the high quantile of crash rates. So we wanted to analyze specifically those areas with high rates of crashes, and then picture those areas in this from the lower interest to the highest interest in buying autonomous vehicles. And we summarized that information. We found quantitative numbers, but in this case, they are just indicative. So I wanted to better show what is the distribution in terms of geography. So for the total number of crashes, we can see that the orange areas are where high rate of crashes are happening, but the interest on buying autonomous vehicles is low. Whereas the purple areas are those areas where high crash rates are happening, but the interest is high. So in this case, the potential reduction is higher. But for the others, policymakers and decision makers should start thinking, okay, what are the possible incentives, or what can we do to address this uneven pattern? So that's for total crashes, but what impacted us the most was for rollover crashes. Rollover crashes happen mainly in the rural areas. And in the rural areas at the same time, the benefits or the interest in autonomous vehicle is less than in urban areas. So for this type of crash, we are calling attention as well. Policymakers and decision makers should think ahead and see what policies are important to put in place so the rural areas also benefit from autonomous vehicle safety features. So that's all I have. These are the research contributions and conclusions, basically to mix two different methodologies to get a more detailed analysis in terms of autonomous adoption and safety benefits. Thank you so much. I will be happy to answer questions.